Hello guys, this is Miss Berta here. For this second example, you guys are gonna find the volume of an oblique cylinder. If you remember, or you go back to the previous example, we saw just a regular cylinder, but when you see the word oblique, clearly this cylinder, because it's an oblique cylinder, it looks like it's leaning sideways, okay? This segment of your cylinder is congruent to this segment right here, and it's more of a slant height. So again, it's sideways. Now, this piece right here, which is drawn for you in red, or this segment here, will be the actual height of the cylinder, and it's always perpendicular. So height is always perpendicular to the base, and sometimes you have to find it, which in this case is not provided to us. But just make sure that you understand that this red segment here is your height, not this one here. This is the slant height that we learned about from previous objectives. But we already know that for the volume, you don't need the slant height, you just need a regular height. So we're gonna have to find this red segment over here. So let's just follow the steps here. So it says here, the volume is still the same, or the same formula as earlier. V equals pi r squared times h, where r is the radius and h is the actual height. Step 1 says identify or find the radius of the base r. And r is just the radius. Okay, so we're gonna find or identify this radius. When I look at one of the circles or the bases on my cylinder, I can see that they gave me an 8 inches segment here, which is clearly the diameter. Well, you need to make sure that whenever you're given the diameter, you don't confuse it with the radius. So I automatically know that the radius is just half of my diameter, which in this case is just 4. Easy. Okay, so the second step says to identify or find the cylinder's altitude or the height. Again, we do not confuse your slant height, which is leaning to the side, with a perpendicular height or altitude, which is the actual height of your cylinder. And that one we're gonna have to find. And how do we find it? Well, because these two segments of your cylinder are congruent, this piece over here is 13 as well. And then I have a 5 inches segment at the bottom of this right triangle that's being formed. And I just need to find this piece right here. Okay. I'm going to just draw the triangle right here so that we can work it out and find its missing side. So I have the perpendicular segment. Then I have this piece right here, 13. I don't have that. And then I have 5 inches here. And of course, if we have two sides on a right triangle, we need to use the Pythagorean theorem to find the third one. Sometimes you might just have an angle and one side. Don't forget that for cases like that, we use SOHCAHTOA, okay? And you're gonna have that on your worksheet. So Pythagorean theorem to find the third side. I know that my hypotenuse is that slant height. So I have 13 squared equals my length here, which I don't know what it is. It's gonna be my height. Let's call it h. H to the second power plus 5 to the second power. Trying to find the height. Let's make this better. The height. Okay, so I have 13 times 13, 169 equals to h squared plus 5 times 5 is 25. And then I'm going to subtract 25 both sides of the equation. I have h squared equal to 169 minus 25, 144. And then I'm going to do the square root of 144. H is 12. So once I find my height, now, which is step 2, height is right here, 12. Now I can go ahead and substitute my values into the formula, which is V equals pi r squared to times h, and then simplify it. So this is going to be step 3 right here. The volume is going to be pi 3.14 times my radius, which is 4 to the second power times the height, which is 12. I have V equals to, when I put that in the calculator, 4 times 4, 16 times pi times 12. And I get 602.9 approximately. I'm going to round it to the nearest tenth. And that's inches to the third power. And that's the volume. Shoot me a text or an email if you have any questions, and good luck with your worksheet.